All right, so in 5-4, we talked about our two last special segments, right? So we started with mid-segments, then we did perpendicular bisectors, then we did angle bisectors, and in 5-4, we talked about what two ones? Alejandro.
Medians and altitude.
Good. Medians and altitude. So what's a median?
I think it's the one in the vertex. It goes from the angle bisector to the midpoint of the segment.
Good. So it doesn't have to be the angle bisector, but it does go from the vertex to the midpoint. And the altitude does what?
Which is perpendicular.
So it's vertex perpendicular. It could be vertex perpendicular to the side opposite, or that's the one that can go outside the triangle, right? If you have to extend the side. The point where all of the medians meet is called what? The orthocenter. And the point where all of the, no, other way around. The point where all the altitudes meet is orthocenter. And the point where all the medians meet is centroid, okay? And there's a theorem for just centroid, not of orthocenter, right? And the one for centroid says what? What do you have to know to do all of this? The 2/3 rule. So it says that from the vertex to the centroid is 2/3 the length of the whole, is what called, it's called the point of concurrency of the centroid theorem, blah, 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 blah. It says from the point, from the vertex, what you need to know is what it says, right? Vertex to where the centroid is 2/3 of the length of the whole median, okay? So that's what you needed for this. It says in exercises 1 to 3, use the diagram to use the centroid of triangle ABC. So the fact that it's a centroid is telling you that those are medians, and from the point where they meet to the vertex would be 2/3 the length of the whole segment. So if BG, if this one here is 9, how do I find BF? You can multiply. That's one way to do it, which I would multiply by what? So I need it, if this segment is 2/3 the length of the whole thing, right? BG equals 2/3 the length of BF. Then 9 equals 2/3 the length of BF, which would mean I'd have to multiply by what? 3/2. So you'd flip it. Okay, so this would be 27 over 2. Wait, did I do it right? 3/2. Yeah. The other way around it is if this is 2/3, okay, take it, divide it by 2, and then add it to the other segment because you have to go one more third. Does that make sense? Yeah? Okay.
Could you also, like when I get like a proportion, like I put that 9 equals, like 9 over x equals
Yep.
2/3.
Yep. Yep, 9 over x equals 2/3. Yep, that's the same thing. So if the GF was on the bottom, if that's what, if it was flipped, right, then it would be 1/3. That's the only difference. That's, other than that, it works. So 27 over 2, or what is 27 divided by 2? 13.5, 13.5. Any of those would be good. All right, then number 2 says if BD is 12, so this time it's giving you this is 12, find AD. So if this is a median, where does it hit? At the midpoint, which would make these two equal to each other, and AD would be 12. And then the last one says CD, which is this whole segment here, the whole median, is 27, find GC. So GC is 2/3 DC, right? Because it's from the actual vertex to where the centroid, or where the centroid is. So 2/3 of 27 is 18. Or divide it by 3 and then double it. It's the same thing. Questions so far? Yes.
Can you go over the first one?
Yeah. Okay, so BG is here, 9, and it wants you to find BF. So the relationship between those is that BG is 2/3 the length of that whole segment, right? Which is BF, right? So then take the values you've got. If BG is 9, then to solve for BF, I could do it in 2 steps. I could multiply by 3, and I'd get 27 equals 2 times BF, and then divide by 3. Divide by 2. And I get 27 over 2. Or dividing by this fraction is the same thing as multiplying by the reciprocal. So you can multiply by times 3 over 2. So you've got to establish the relationship first, because sometimes you might get the 1/3 part. Sometimes you're going to get the big part and have to take 2/3 of it. So you got to figure out what the relationship is first. But you couldn't have done any of that if you didn't know what the word centroid means, right? So for quiz, you don't have to worry about centroid just yet. Okay, what you do have to worry about is the first two, which are, what's it called, where the perpendicular bisectors meet? Circumcenter. And where's the angle bisectors meet? In center. Okay, those are the two you have to worry about for your quiz. But then the test rolls around, and you throw in centroid, and you throw in, what's the other one? Orthocenter. And you've got to know by looking at it that that means either medians or altitudes or which one it means. And then from there, what's the theorem that's attached to it? Okay? So we're going to review 1 through 3 today. But then you want to make sure that you're keeping track all the way up.
Are you going to put the answers to the review on here?
All right, so this one says find the centroid of triangle ABC. So again, centroid is where the 3 medians connect. And in order to find the median, I would have to go from the vertex to the midpoint of the opposite side. So how can I find the midpoint if I know the 2 points? What's the midpoint formula? Evan. Okay.
X1 plus X2 over 2, and then Y1 plus Y2 over 2.
Okay, so add the 2x's divided by 2, add the 2y's divided by 2. So to do that first, I'm going to identify these points. This would be negative 3, 1. This would be 1, 5. And this is 5, negative 3. So if I want to find the midpoint of AB, I would do negative 3 plus 1 over 2, and then 1 plus 5 over 2. Negative 2 over 2, which is negative 1, 6 over 2, which is 3. So negative 1, 3 is the midpoint of AB. And then I'm going to do the same thing to BC. 1 plus 5 divided by 2. 5 plus negative 3 divided by 2. Three, 1. And then the last one is AC. So A is negative 3 plus the x of C, which is 5, over 2, and 1 plus negative 3 over 2. And I get 1, negative 1. And then where these 3 meet is my centroid, which is 1, 1. Well, without a ruler, the only way to know the exact midpoint is using the midpoint formula. So an eyeball, remember, eyeball never works. Doesn't work. You have to give it justification. So if this kind of question was on your quiz, I'd be looking for the work that you found the midpoint. Okay? The eyeballing helps you to see if you're, at least on track or way off, but.
Well, what I did is I saw where the line intersects a point fully, and then I counted.
You better hope that that's right, but what if it's not? Yeah. Yeah, you're doing the reverse of the midpoint, yeah. At this point, you better know how to find a midpoint. That's all I got to tell you. Okay, that's not something that's going to go away. Nick?
You want to show me work on the three? You want to mark it off?
Yeah, you got to have work. Alexis. Bottom here, number 5 says which type of triangle has its orthocenter on the triangle. So remember orthocenter, what do we know about the orthocenter? What's that mean? It's the point of concurrency of the altitudes. And remember that there's 3 different places that an altitude can go depending on the triangle. If it's an acute triangle, where does it fall? In. If it's right, on. And if it's obtuse, out. So this one being on the triangle means that this is a right triangle. So the 2 with the perpendicular part, which is the altitude and the perpendicular bisectors, are the ones that meet in, on, out. The others are always in. So the quiz is going to cover 5.1 to 5.3. 5.1 started with mid-segments. Okay, and mid-segments are what? What's the definition of a mid-segment? I'll give you a hint. It starts with a segment. Uh-huh. Good. Segment that connects the midpoint of 2 sides of a triangle. So definition of a mid-segment is that it's a segment that connects the midpoints of the sides of the triangle. And then there's a theorem about mid-segments. It's called the mid-segment theorem. What does it say? What's true about the mid-segment? So there's 3 mid-segments in a triangle, that's one thing.
It's parallel to the side and half this one.
Good. So the mid-segment is parallel to the 3rd side of the triangle, the one it doesn't intersect, and half its length. So you had things like, if this is 20, this is 10. If this is 15, this is 30, that kind of a thing. Okay, then you had coordinate problems. So it would say something like the vertices of a rectangle, let's say, are A0 and B0, find the other 2, okay, so it could say something like that, where you're actually putting this on a coordinate grid. So for these, I would start at 0, 0, so I know 1 coordinate. A0 means I'm going to the right A amount, so I don't know how far A is. B0 means I'm going up. B amount, and I don't know how much B is. And then my last coordinate would be what? AB. So this could be a rectangle, it could be a triangle, it's been a right triangle, it's been an isosceles triangle, anything like that. You've got to be able to map it out.
The top part largest.
Like let's say that this now asked for the, oh, I'm sorry, that's what you're saying, 0B here. Yeah, that should be 0B. Let's say it said find the length of the diagonal. Fix this one. How do I find the length of a segment if I'm given coordinate points? The distance formula. Come on. So I would say the square root of, let's say that this is my x1, y1, x2, y2. So a minus 0 squared plus 0 minus b squared. So I'd get the square root of a squared plus the square root of negative b squared. Which is the square root of a squared plus b squared. Yep. Sure. So if this was a numeric value that could be simplified, let's say I ended up like the square root of 25a squared, okay? This cannot be simplified. So two variables that are separated by a plus or minus cannot be simplified. But something like this can be. So I would square root the 25 of that, which would be what? 5. And then square root a squared, and I get what? So this is the trick on square rooting variables. That's actually the absolute value of a, because you don't know what a is, and distance cannot be negative. So if it can't be simplified, like a squared plus b squared, I would leave it alone, okay, because we're not doing Pythagorean theorem just yet, which eventually we'll get to. But if it can be, if I've got 25a squared or 25b squared or 25y squared or something like that, then I've got to square root it. If it was 144y squared, I'd end up with 12 absolute value y. That can't be simplified. So I can't break it apart. It has to be multiplication. That would stay exactly how it is. Yep.
Is there going to be one with variables and the answer will be?
There's going to be one with variables. Yeah, you're going to have some sort of variable involved there. And then you're going to be finding either a length or a distance between them or something like that. Midpoint, any of those things you might be able to see. Okay, so then 5-2 is perpendicular bisectors. And 5-2 and 5-3 were structured a lot alike. It gave you the introduction into a certain kind of segment. Then what happens when those segments meet together inside a triangle, what's it called, and then what's the theorem based on that. So a perpendicular bisector is what? Its name tells you what it is, right? It's a segment, ray, line, or plane, because it can be any of those, that intersects. Or sorry, it's not just intersects, that is perpendicular to a segment at its midpoint. So you've got to have the right angle, and you've got to have the midpoint. that line would be the perpendicular bisector. Oops, Daisy. That line would be the perpendicular bisector of the green segment. And then we had something called the perpendicular bisector theorem. Before we even put it inside a triangle. And what was the perpendicular bisector theorem? What's true about a point on the perpendicular bisector? Good. A point that lies on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So I could say something like AB is equal to AC. Or if I had an X and a 10, I would say that X is 10. And the reason is the perpendicular bisector theorem, or if you don't know the name, then you write it out, that a point that lies on the perpendicular bisector is equidistant from the endpoints. And then the converse to the perpendicular bisector theorem said if a point is equidistant, from the endpoints of a segment, then it lies on the perpendicular bisector of that segment. So if I had something like this, I could say that because AB is equal to BC, B lies on the perpendicular bisector of AC, or BD is the perpendicular bisector of AC. Then we put the perpendicular bisectors inside a triangle. Okay, and we said that they have a point of concurrency, right? And the point of concurrency, which is the point where the three meet, there's three of them, right? Three perpendicular bisectors in a triangle. Point of concurrency, or point where they all meet, is called what? Circumcenter. Where do they meet? Is it always inside? No. Okay, if it's acute, they meet inside. If it's right, they meet on. And if it's obtuse, they meet outside. I'm not done. I'm going to keep going if you want to wait, Sophia. But if you don't know this stuff, I'm telling you, writing it down is going to help you remember it. And then the point of concurrency of a circumcenter or circumcenter theorem. So the names like perpendicular of concurrency of perpendicular bisectors, or the circumcenter of a theorem, which said what's congruent? From the circumcenter to what? Good. So circumcenter is equidistant from the vertices. So all of those little segments would be congruent. So you've got to look at a triangle. It might ask you, what's it called where the perpendicular bisectors meet? So there might be a little bit of vocab, and so that would be circumcenter. And then it might be sometimes always never that the circumcenter or the perpendicular bisectors blank meet inside a triangle, and it's sometimes, okay? Or it could be that you've got to draw a diagram and there's parts of it labeled, and you have to know that those are the perpendicular bisectors, and from where they meet to the vertices is what's congruent. And then came the angle bisectors, and we did the same thing with angle bisectors. So we talked about the definition of an angle bisector. So it's a ray that splits an angle into two congruent angles we had an angle bisector theorem. Which set a point on the angle bisector is equidistant from the sides. What was special about this one? Could I say that these two are equal? No. What did I have to have? Emily? Good. I have to have a perpendicular segment connecting the two sides. Or connecting, the angle bisector to the sides. The angle bisector theorem converse. Said the reverse. If a point is equidistant from the sides, then it lies on the angle bisector. Okay, and then just like the the perpendicular bisectors, there are three angle bisectors in a triangle. So if I had a triangle, one would be about here, here, and here. The point where these meet is called the incenter. So angle bisectors is called, or point of concurrency for angle bisectors is the incenter. And the incenter is always inside a triangle. no matter if it's acute, right, or obtuse. So perpendicular bisectors meet in on out, and angle bisectors are always inside. And then the concurrency of angle bisector theorem tells you that the incenter is equidistant from the sides of the triangle. So from here, which you would have a right angle, to here, a right angle, and to here, would all be congruent. All right, so that sums up the stuff that you need for the 5-1 to 5-3 quiz. There's a Quizlet link on the review assignment, or actually on the quiz assignment itself, and then there's some extra practice worksheets there as well.